Okay, Ryan, earlier today during the homework, we looked at a problem where we actually factored it out and solved that way. And then we also completed the square, or we used the square root to solve for it, and it was much faster. Sometimes it's faster to do what we call completing the square. Sometimes it's not. Sometimes it's just what you feel more comfortable with, right? I mean, we're algebraists. I'm showing you lots of different ways, but sometimes it's just which you feel more comfortable with. But this is another way of solving quadratic equations, and it's called completing the square. Now this first example here just helps us practice, okay, making a perfect square. Cool, let's look at this first one. It says, this one says x squared plus 14x plus something. What would this something be in order to, make this a perfect square binomial? Okay, perfect. Perfect. Here are the questions that Kula said 49, for those of you who didn't hear. And here are the questions that went through her head. I don't know if she knows this, but I'm going to tell her what she was thinking, which is what I like to do, tell people what they think. Okay? Kula said, there are two numbers that add together to give me 14. And they multiply to give me a perfect square back here. So what number added to itself, when multiplied by itself, what do I get back here? She said, well, okay, well, let's just take 14 and we're going to divide it by 2. And it gives us 7. So that means that 7 plus 7 will give me 14. 7 times 7 gives me 49. Now this is a perfect square. What is it? What is the perfect square? Harrison? X plus 7. Because 7 plus 7 equals 14. 7 times 7 gives me 49. Perfect. All we have to do is take the number in front of the x and divide it by 2. And then we square it to get the back number. Okay? So now, given that information, Lauren C., what do I get back here to make this a perfect square? Okay. All right, I'll give you a second, but don't use a calculator. I want you to use some fractions here. Because we definitely don't want to get all mixed up in some decimals. Okay.
Is it 17 and a 4?
Well, I don't know. I don't like that mixed number. I don't know what that is. That's hard for me to figure out. 7. What is it? What was it before it became a mixed number? Oh, don't tell me you did 17.25 and you said, oh, he doesn't want decimals. I'm going to say 17 and a 4.
No, it was 17 and a 4.
What was it before it was 17 and a 4?
17.25.
That's what I'm saying. I don't want the decimal. I want the fraction. And I don't want mixed numbers.
68 or something? I don't know.
Okay, here's the thing. Let's go back over here. Kulis took 14 and divided it by 2, and she got 7. And then she squared that 7 to give us the number that goes in the back. We're going to do the same exact thing here. Let's divide negative 9 by 2. Don't change it to negative 4.5. Let's leave it as negative 9 over 2 squared. When I square that, what do I get, Lauren C?
81 over 4.
I get positive 81 over 4. Perfect. Now, let me ask you this. That being the case, what is that binomial square? What is the binomial square? Over here we said it's x plus 7. Oh, you mean it's x plus what I got after I divided it by 2. Okay. What do you think this one over here is? It's easy. It's easy. I've got 5 seconds left. X minus 9 over 2.